Hello, my name is Gregory Osborne, video game audio composer and implementer. In this video, we're going to do a first steps introduction to the Reaktion library for Unity by Keijiro Takahashi. What Reaktion is an audio-reactive animation toolkit for Unity that allows you to take audio input and output animation effects, be it particle systems, material changes, or transform-related effects. This library gives you the opportunity to have your animations way more directly reactive to audio. This is of particular interest to people like me trying to develop interactive audiovisual experiences because it sets up all the logic and calculations for you. Let's get started.
To download the Reaktion import package, go to Keijiro's GitHub and click on Reaktion. Then download a zip file by clicking on the clone or download button. You're going to want to save it to a place you can find. Next, create your Unity project. Once inside your Unity project, go to the Assets dropdown, click on Import Package and select Custom Package. Find the Reaktion Unity package that you downloaded, click Open, and then Import. An interesting thing about importing the package this way is that you don't automatically import the sample scenes. So if, like me, you want to see a working scene to reassure yourself that everything isn't broken, go to the Reaktion Master folder, go into the Assets folder, then click and drag the Reaktion Test folder into your Unity project. Back in your Unity project, clicking on the Reaktion Test folder will reveal 5 scenes that you can use to explore more of the features of this library that I won't be able to get to in this video. Now it's time to go over how Reaktion works. It uses 3 steps. First, an injector gives an impulse signal, whether that be from audio, from a beat injector, from your microphone, or even MIDI information. Next, a reactor links up with that injector, takes the signal information, and does a bunch of calculations to make that information more usable for animations, which it then outputs. Lastly, a gear, which is generally associated with some specific animation, takes that reactor output and turns it into pretty visuals. I'm going to create a new scene where we'll set up a very basic chain. I'm going to create a game object with an audio source that plays that audio on a loop. On the same game object, we're now going to add the audio injector, which you can either search for or find in the injector folder of the Reaktion folder in your assets. What you'll notice is that you have the option to mute the audio coming from your source, meaning you can prepare a stem of audio that only has the stuff you want the animation to react to, and you don't have to hear it. You'll just have to make sure that if the music is interactive, things don't get unsynced because you forgot to change the input audio as well as the playing audio. I'm going to uncheck this for this demonstration. Next, I'm going to create a separate empty game object and throw the reactor script on there. Now, it'll default to auto-binding to an injector, but I prefer to know exactly what it's referencing, so I'm going to change the injector mode to bind by reference and make sure it's referencing the object with the correct injector. We'll come back to these settings over here later. Finally, I'm going to make a cube, and I'm going to throw a gear onto it, specifically the transform gear. I'm going to bind the reactor it's listening to in the same way we did before, selecting bind by reference and dragging in the object with the reactor that we want to listen to. I'm also going to turn position on, having it react along the y-axis. I'll change the max distance to 5 so the effect is obvious, and when we play our scene, the cube bounces to the music. Success! Let's go back and look at another option for an injector, the beat injector. On this object, instead of an audio source in the audio injector script, instead we're going to have just the beat injector script. We'll also go back to our reactor and reassign it to this new object. When we hit play, we'll notice that the cube bounces at 120 BPM, as is the default setting. We can also mess around a little with some of the default options, such as having it include subdivisions, or imitate a groove. Possibly the most important feature of the script is the ability to draw in your own curve. Keep in mind that this curve lasts for 1 beat according to the BPM calculations. So if you want to draw a curve for 1 bar or even 2 bar loops, you have to divide the BPM by a factor of how many beats you want to be represented in this curve. Another advantage of the beat injector is that you can adjust tempo on the fly very easily. Again though, changing this groove might get a little complicated, so watch out if your music isn't just the same groove over and over again. Now, the gears are a complete rabbit hole in and of themselves, but the last part of this video is going to be a look at the settings in the reactor component. First, You gotta assign the injector, which defaults to auto-bound, though I'm not sure exactly how this works. The other options are to bind by reference, such as dragging a game object with the injector on it into the inspector, or to bind by name, where you type in the name of the game object that has your injector on it. The amplitude curve is the final thing your reactor output goes through, and it adjusts the outputs if you want to weight the outputs towards a specific value. Gain control and offset control I'm going to skip. From what I understand, they're mostly for use with MIDI in live performance. Sensitivity is essentially how quickly the actual output of reactor approaches the calculated output. This setting is most visible when it's low, and the animation takes a bit to slide up every time audio plays, or sometimes slide down. The decay speed, on the other hand, is how quickly the output of the animation fades by default when no sound is detected louder than the current output. In other words, when it's silent, how fast does it take for the output of your animation to return to 0? In the audio input options, there's 4 sliders. Headroom as a term symbolizes how much space under 0 dB you expect to find unused by the audio. This is primarily used to increase the gain into the reactor and can be useful for debugging purposes if you have multiple reactor plugins that you're looking at the peak of. Dynamic range and the lower bound are the most noticeable changes you can make in the audio input settings. The lower bound is the volume in decibels at which reactor will output 0, and dynamic range is how many decibels above the lower bound it takes before reactor outputs its maximum value. So, for example, if you really just want a sort of kick impulse that doesn't have a ton of nuanced volume information, you can keep the dynamic low. However, if you want to reflect different volumes from your injector very explicitly along a gradient of animation, then you want your dynamic range to mimic how many decibels of range your input is giving. You'll want to make sure the loudest input value matches your lower bound value plus the dynamic range value. Fall down is separate from decay speed and is primarily used to adjust for changes in general volume from your inputs. If you want Reactor to adjust its bounds so that quieter sections of your music will still be just as reactive as the louder sections, then you want the fall down value to be high so that Reactor more closely tracks what the general volume is of the section and adjusts accordingly when your volume drops to boost the output. However, if you want the quieter sections of your song to have noticeably less output, then you want the fall down time to be much lower, or even 0, so that the input's decrease in volume isn't adjusted for.
My next video will dive a little deeper into linking up Reaktor to a better interactive audio engine than Unity's own, that being Wwise. One of the key advantages there being that instead of attaching an injector to an audio source that's playing or even to a microphone input, you can instead link up an injector to a bus in Wwise, which opens up new avenues of interactivity in audio that will be much more difficult to achieve in Unity. Thank you for watching. I hope you're just as inspired by this library as I am.